Hi guys, welcome to Mathematics Squared. In part 3 of Basic Concepts in Geometry, first chapter of class 9, today we will see conditional statements and converse and theorems and their proofs. Now, what are the conditional statements? Now, for example, if we have this statement, the diagonals of rhombus are perpendicular bisectors of each other. Then the statement written with the if and then phrases in it, then the statement is called as conditional statement. So this statement we are written in a conditional state format as if a quadrilateral is a rhombus, then its diagonals are perpendicular bisectors of each other. Here we have used if and then, that is marked as a yellow underline. Now see, the part that follows after the if, it is called an antecedent of the statement. A quadrilateral is a rhombus. This is an antecedent for this statement. And the part that is after then, it is called as consequent of the statement. It is its diagonals are perpendicular bisector of each other. Now, what is the converse of a statement? In a converse statement, the conditional statement, we only interchange the antecedent and consequent. Like that. Now see, here if the diagonals of quadrilateral are perpendicular bisector, this becomes our antecedent in converse statement, which was a consequent of the conditional statement of each other, and then it is a rhombus. Rhombus is a quadrilateral that was our antecedent in conditional statement. So converse is just a antecedent and consequent are interchanged in the converse. So now theorem. What is a theorem? Theorem is basically a property that we proved it is true. We prove it logically. So logically when we prove any property, that is called as a theorem. Then theorem can be proved in two different ways. One is called as direct proof and another one is called as indirect proof. So the first theorem which we are going to prove is the opposite angles formed by two intersecting lines are of equal measure. For example, here opposite angles will be angle AOC and angle BOC. Otherwise, another pair of opposite angle will be AOD and COB. These both pairs of opposite angle, we want to show that they are of the equal measure. So here we will have the given that line AB and line DC intersect at point O. But they intersect such that O is between A and B and O is between D and C. Called betweenness. If you want to not know the concept of the betweenness, then I will share the link of the first part of this chapter in the description. So do watch that video, then you will let to know what is betweenness. So now what we want to prove? We want to prove that those pair of opposite angles are equal. So our proof will be those pairs of opposite angle should be of equal measure. That is, angle AOC should be equal to angle BOD and angle AOD is equal to angle BOC. Now both they will have the same explanation. So first we will prove the first one, that is angle AOC is equal to angle BOD, then automatically it is similar to the second angle pair also. So now proof. Now see, we have angle AOC and angle BOC. These form a linear pair of angle. Now what is a linear pair of angle? Angles those share one common arm. Now arm you can see, that is ray OC. That is a common arm for both the angles. Then their total sum is how much? 180 degree. Means they are in a linear pair of angles. So from linear pair of angle we will have angle AOC plus angle BOC is equal to 180 degree. That is from linear pair of angle. That is from linear pair of angles. Now similarly we can write that angle AOD is plus angle BOD is equal to 180 degree. Similarly we can write that angle AOD plus angle BOD is equal to 180 degree because those also have a common arm OD. So their sum is 180 degree from linear pair of angles. Similarly, we can write that angle POC plus angle BOD is equal to 180 degree as they also share a same one arm, that is OB. So those are also linear pair of angles and we can write. Now as both the equations has the right hand side as 180 degree, so our left hand sides will be equal to each other. So we can write angle BOC plus angle BOD is equal to angle BOC plus angle AOC, that is from 1 and 2. That is from 1 and 2. Now you can see that both these side has an angle BOC and angle BOC. So if we take it towards the left hand side, then it will be automatically minus each other. So we can cancel it and we can write angle BOD is equal to angle AOC. And that's our first proof. And therefore we have proved our first proof. Now similarly we can prove that angle AOD is equal to angle BOC in this similar manner. So in this way we have proved our theorem, that is logically we have proved. So the statement that is the property that is proved logically true, it is called the theorem. In this way, we have proved the theorem in a direct proof way. Now we will see the next property which we will prove in an indirect way of proving. Now the second statement is a prime number greater than 2 is a odd. Now if we will write the conditional statement of this statement, we will get if P is a prime number greater than 2, then it is odd. Now P we has considered as variable, means any unknown number. It is greater than 2, then it should be odd. So now here the P is a prime number greater than 2 is an antecedent and P number is odd, that is a consequent. Now here we are going to do it by the indirect proof. Now indirect proof, what we do, we assume that the consequence is a false. Now our consequent is p is a odd number. Therefore, we will consider as a p is a even number. Then using that, we accept the property earlier and then we start arguing it step by step and reach to one conclusion. And that conclusion is contradictory with our antecedent. Now, once we come to the conclusion that is contradictory to the antecedent, then also we have to recognize that our consequent which we was assumed that was also false, then the given statement is true. So let's prove now. So our given is p is a prime number greater than 2. Now, as it is a prime number, so the divisor of the prime number should be also 1 and the number itself. That is 1 and number is our p. Now, what we want to prove that p is a odd number. It is a odd. So, p is a odd number. So now, what was our first step? That we will assume that our consequent is a false. Our consequent was p is an odd number. So we will let p be a even number. Therefore, now if a p is even number, means the 2 is also a divisor of a p number. Therefore, a divisor of p is 2 because every even number is divisible by every even number is divisible by 2, right? So now, but it is given that p is greater than 2 and it is divisor or its divisor are 1 and p. Therefore, but given p is a prime number greater than 2. This is given to us. Therefore, 1 and p are only the divisor of p. This is our equation number 2. Therefore, statements 1 and 2 are contradictory. Because now see, here we say that 1 and p are only divisor, and here it is 2 is also a divisor. So these two are the contradictory statements, and therefore that our assumption that p is an even number is false. Therefore, our assumption p is not odd is false. And therefore, this proves that number greater than 2 is odd. In this way, we have seen our indirect proof. In indirect proof, what we do, we assume that our consequent is false, and then we come to one conclusion that is contradictory to our antecedent, and therefore we have to assume that our consequent which we was assumed was false, and this way we can prove this statement in indirect proof. Now we will see the practice set 1.3. Start with the practice set 1.3. The practice set is very simple. We have to just write the statement in if and then and the converse of the statements. So first question is, write the following statements in if then form. The opposite angles of a parallelogram are congruent. So then if and then form of this statement will be, if a quadrilateral is parallelogram, then its opposite angles are congruent. The second question is, the diagonals of a rectangle are congruent. Then it can be written as, if a quadrilateral is a rectangle, then its diagonals are congruent. Third question is, in an isosceles triangle, the segment joining the vertex and the midpoint of the base is perpendicular to the base. So its if and then statement will be, if a triangle is isosceles triangle, then the segment joining the vertex of a triangle and the midpoint of the base is perpendicular to the base. Right? Now next question is, write the converses of the following statement. Now first question is, if the alternate angles formed by two parallel lines and their transversal are congruent. Now it can be written as, its converse can be written as, if the alternate angles made by two lines and their transversal are congruent, then the lines are parallel. Similarly, the second question is, if a pair of interior angles made by a transversal of two lines are supplementary, then lines are parallel. So its converse will be, if two lines parallel are intersected by a transversal, then the interior angles formed by the transversal are supplementary. Similarly, the third question is, the diagonals of a rectangle are congruent. Its converse can be, if diagonals of a quadrilateral are congruent, then that quadrilateral is a triangle. Quadrilateral is a common of all square, rectangle, rhomboid. So to mention that one of the quadrilateral whose diagonals are congruent, then that quadrilateral will be rectangle. So in this way we have completed the practice set 1.3 and we have completed the entire chapter basic concepts in geometry and all the practice set. So in next video we will say the problem set of this chapter. Entire problem set we see, and if any problem let me know in the comment section. And do like and subscribe and share Mathematics Squared videos with your friends and family. Thank you.